So before we start, I just want to introduce this page, which has all the materials that we need for this part. So basically what I'm going to tell is the first part, which is explore NOMAD entries. You can find everything documented here. If you couldn't follow right now, but try to follow as much as you can. And stop me whenever you feel I'm too fast or you couldn't follow the hands-on part, or either ask your question in the chat or speak up and directly stop me and ask the question via Zoom. So yeah, let's get started and start simple. What I'm going to do is to actually use the filter bars, the filter menus that Adriana just explained, and start with a very simple question. So the first question is, how many entries of hexagonal boron nitride are available in NOMAD? And there are some hints. The hints are use the element formula tab and filter and use the structure symmetry tab for filtering the hexagonal thing. So I come to NOMAD -lab.eu and open NOMAD button at the top right side. This is the landing page, which is basically the Explorer with all entries, and I have my search filters here. I can immediately see here that there is a filter for material element formula, the periodic table. So I click on boron, and then I click on nitrogen. And now I'm interested only in the materials that contain exclusively boron and nitrogen, not the ones that boron or nitrogen is a dopant or something else. That's why I click on this checkbox here, only the compositions that exclusively contain these two atoms. Okay, up to now, I have all the materials filtered that contain exclusively boron and nitrogen. However, I'm looking for hexagonal symmetry. So exactly the next filter here is the symmetry. Then I see there are different options here. And you see like Bravillatius is here, crystal system is here. There are other things which is related to symmetry. And once I click on hexagonal, I can see that the other options that are related to, for instance, the cubic symmetry disappear. Just look at here. All right. I have all my search criteria selected. So this is the number of the entries that match my criteria, exclusively having boron atom and nitrogen atom having hexagonal symmetry, and this is exclusive. Okay, that was easy. Let's go to the second question. What is the range of band gap of hexagonal boron nitride in NOMAD entries? We are not talking about the real world. We are just talking about the entries that we can find in NOMAD. And we want to know which values did people report for hexagonal boron nitride band gap. And the hint is here, use properties electronic filter. So keeping these filters, then I search for electronic properties filter. It's not there. And I see there are some properties. The subname is electronic. And I can look here. Here is a, let's say, histogram for this. The range is a bit weird from 3.9 to 7, but it's all right. It's calculations. We don't know what assumptions they took into account, but this is the range of the band gap that people reported in the entries of hexagonal boron nitride in NOMAD. Okay. How does one answer the first question with the search field? Actually, if you're talking about this search field, you can find all of these filters that you find at the left sidebar here. But the point is that you should know what keyword to search. But for instance, if I search for band gap, space, I can see that the band gap is stored somewhere and I can reach that. But let's skip it for now. We can come back to this later. In fact, when we are talking about the widgets. Let's go to the third question. How many entries in NOMAD have calculated band gap of hexagonal boron nitride between 5.9 electron volt and 6.5? Again, I can use a slider here to narrow down. Let's go back to the filter that I had. So it was under properties, under electronic. I can use a slider or directly put the numbers that I was interested in. So 5.9 and 6.5, and then press enter. Okay, I can immediately see that there are only 3 entries, and this is the range of the actual value of the band gap of boron nitride. If I want, I can go to the entry and see what they have done, which method they have used. For instance, this is calculated by a DFT with this DFT method, FHI aims, and there are other information that I can access. Okay, let's go back. All right. Up to here, everything was rather easy, but now let's consider a bit more complicated example. So imagine that I'm doing my research in solar cells, and I fabricated a device. And the device structure is what you can see here. You have, so the main material, the main absorber layer is a perovskite material. And then I have some electron transport layer or ETL on top with some contact. There is a hole transport layer on bottom of the absorber layer. All of them are on top of a substrate or basically a transparent conductive layer. So what I fabricated is I have gold as contacts. My HTL layer is spiroometot. This is a well-known material for the HTL layers. My perovskite material is cesium, lead, bromine, iodide. The ETL is titanium oxide in a compact form. And my contacts is either FTO or indium tin oxide or whatever. And everything is on top of a substrate, maybe SLG or pseudo-laminate. Now I want to know what information or what entries are in NOMAD that help me to improve my research, get some insights through the already existing efficiencies, short circuit current densities, open circuit, and so on. So let's go to the first question. How many entries in NOMAD have the elements of the absorber layer? Cesium, lead, bromine, and iodine. So again, this is easy. I need to remove these filters first. I can just do that with this crossing here. And actually, this also removes all of them. This cross button with right side. And then again, I start with the periodic table. I can even pin the periodic table to my main search interface. So I had cesium, lead, group 6, bromine, and iodine. Okay, I can see that I have about 7,458 entries that have these. I can even now go and click on only compositions that exclusively contain these atoms. And now I see that it's much more reduced. Okay. So that was the first task. That was easy, just using the periodic table. The second one, how many of these entries include solar cell data within this as an absorber layer, spiroometot as HTL, and titanium oxide compact form as ETL? Again, I can just come here, look at the filters, start from the top. I don't see anything. And then I see, okay, there is a solar cell filter here. And I start seeing from the top. Okay, the absorber layer is here. The method of preparation is here. Electron transport layer, that's what I want. Let's add it here. And also the hole transport layer. Let's add it here. I forgot what was the materials. So spiral method was the HDL, titanium oxide in compact form was the ETL. So I choose it here, and a spiral method. And I see that once I click on this, the other options just decrease or disappear. And yes, that's finally the search narrowed my entries to 251, which is the answer that I was looking for. And again, I can look at these entries or apply some other filters. For instance, I know how to apply the band gap and so on now. Yeah. So let's go to the next question. Show the range of the reported efficiencies from these materials. And the hint is to use the histogram widget for x-axis, start typing efficiency. So where are the widgets? So there are 4 widgets here that I can see. One is the periodic table that we already had, that we don't want now. And I'm interested in the histogram widget. So here is what I can type for the efficiency, type for the x-axis of a histogram, and I thought the hint was efficiency. Just intuition tells me that I'm looking for the efficiency. And then while I'm typing, NOMAD searches and sees that this efficiency is an indexed metadata that has been stored in NOMAD and offers me the location that is being stored. I just don't need to know the location. I just see the suggestion and click on it. And then I can just give a title. There is no dimension, there's no unit, of course. I can say if I want to see the efficiency in linear or logarithmic or other options, and a general title for the widget. Title and click done. And that's what I was interested in. And this is, let's say, the most complicated thing that we can think of. So the question is, show an overview of the available entries with info about short circuit current density, efficiency, and open circuit voltage. And the hint is that I should use the scatter plot widget. And other hints for what should be chosen for x-axis, what should be chosen for y-axis. And this is basically what solar cell researchers would like to see. But let's go and use the widget. So here I see the widgets again on top of the page. I'm interested in scatter plot. So you don't have the hints now, but I do actually. Maybe I can just show it up once again here. For x-axis, I should search for open circuit voltage, for y, efficiency, and for color, the short circuit current density. Again, I start typing open, and I see a lot of other options. So already here, it's suggesting that there is a metadata stored in NOMAD with open circuit voltage. And I can even choose a unit for it. Let's choose watts now. The y-axis was the efficiency. And again, I can see it here. Doesn't have any dimensions. And I want everything to be linear. That's why I don't change it. And this was short circuit current density. And I can choose a title and so on. And let's click on done. Okay, and that's the widget that I have. So this is basically showing me these 251 entries, and this plot is interactive. I can just scroll here, zoom in, go to a certain part, or just make it showing up on top of everything else. And I can even see when I hover on the individual data points, I can see the information about each entry. For instance, I'm interested in this one, which has the highest efficiency. I just need to click on it. And this brings me to the entry page that this data point has been extracted from. Okay, so we learned how to use the all entries to search for our specific properties, or let's say metadata that has been structured in NOMAD and are searchable. However, for the special case of solar cells, and also for other use cases, there are specific apps that we call in NOMAD. And so in the Explore menu, just come and you see that there is a solar cell section, and just click on the last one, which is the solar cells. And this gives you a pre-made dashboard with, let's say, most useful widgets that the person might need in order to explore NOMAD data entries for the solar cells. You can see, again, the periodic table here, the device stack, the method of the absorber layer fabrication, whole transport layer that we already chose, electron transport layer, and this was the plot that we already plotted ourselves, I think. Yes, and again, for the architecture of the solar cell, and this is interactive. As I said, you can just click here. All the data which had the NIP architecture are now disappeared. The unknowns are disappeared, and so on. And for instance, you can search for band gap. Let's say we are interested in the cesium, lead, bromine, iodine entries that have a band gap between 1.7 and 1.8. And you see that NOMAD updates the entries that match this filter criteria. And finally, what is shown to you is the ones that match these filters. And yes, and then you can see the entries here. You can even add, for instance, here we have the references. This is basically a reference that the uploader gave to this entry. You can also change these columns by clicking this thing here at the right side, top right side of your entries, and choose other things. If you want to know about the author, or yes, other options. Now already all the let's say necessary options are already checked here. Okay, that was what I wanted to say for this part.